All right, we are continuing our study of statistics. 1.1 was just talking about what statistical questions are, looking at numerical versus categorical. Then the next lesson was about how if you collect your data, it's really important that you know how to organize it in a way that you actually can interpret it and make some conclusions about it. And now what we're looking at is just the graphs and some different types of names with how the data is distributed. So the start thinking part here says which of the following does not belong. What I had the students do instead of say which does not belong is look at each one and tell me what is different about that one compared to the others. For A, they said that most of the data was centralized in the middle and then it kind of trailed off on both of the sides. For B, they said most of the data was on the left and the right on the sides, and then there wasn't way too much in the middle. The next one, it was constant across the whole entire thing. And then D, it seemed like most of the data was pulled to one of the sides. The next thing that students did, this is a super quick lesson, is they had these different dot plots and different box plots, and they had to match up which dot plot went with the box plots. Now, the thing that gets a little confusing here is they forget that the box plots are divided into quartiles, and you're going to have 25% of the data in one place, then 25, 25, 25, so it's split up into fours. People always thought that the bigger the space is, the more data is actually in there, but that's incorrect. It's the same amount inside of each one of those pieces, and if the pieces is compressed, then it's got to be more densely populated inside there. It's kind of like if you take 1 acre in Doney Park, you might have one single family in that acre, whereas if you take an acre in Manhattan, you might have 1 million people inside that, or probably not 1 million, but a large amount. So it's the same amount of land, and it's going to be much more densely populated. So right here, it's when we're looking at this, you can look at A. Let's look at A. So it looks like the first quartile, or that first quartile, and then that last one are very small. It's between 8 and 9, and the other one is between 15 and 16. And you still have the same amount of data that's in the other quartiles, but it's pushed between just the numbers 8 and 9, whereas the other one is between 9 and 12. It's stretched out much more. So you had to ask yourself, which one of the dot plots goes along with that? And you could see number four, you have quite a bit of data on the ends and then not way too much in the middle. So you knew that A went with 4. The next one looks like they're evenly spaced. The first quartile, second, third, and fourth, they are equally spaced, which means there is an equal amount of data points in each one of those, and that would be 3. Because that one you can see there's an equal amount of data points as you have half of the data on one side, half the data on the other. And also you have the quartiles, so it's equally spaced, an equal like density of data points. Now the next one, you could see that most of the data was centralized. Most of it is between 50% is between 11 and 13. So when you look at this, the only graph that makes sense for is number 1. So 1 is C. And then the last one, this one, you see that the first quartile, where 25% of the data is going to be, is squished all the way really tightly to the left. And that one would be number 2. So you guys can see my little justifications on there. There's actually names for this. So if something is bimodal, that would be graph number 4 and A. The reason why is the bimodal means you have those 2 spikes on the left and on the right, not way too much going on in the middle. The next one is symmetric and bell-shaped. So there's such thing as just symmetric. For example, bimodal would be symmetric, but it's not bell-shaped. If you say symmetric and bell-shaped, or just bell-shaped, is definitely going to be symmetric. The one that looks like a bell, where most of the data is centralized in the middle, would be 1 and C. And the next one is skewed. So the one that is skewed, either left or right, would be numbers 2 and D. Now, the only confusing part about this is just that if you looked at number 2 and you wanted to say, is that skewed left or right, or we'd really think that that would be skewed left because most of the data is on the left, but it's actually skewed right. The way that the stats teacher explained it to me is that if you had a bell shape and then you grabbed the right tail and pulled it all the way to the right, you're skewing it to the right, then the tail points in the direction that you are going to be skewing it. So number 2 is actually skewed right, not left. So that one would be skewed. And then the next one is the one that is uniform. It is uniform across, would be 3 and B. So those are the major names. The next thing we talked about were just situations where if you collected data and put it into a dot plot or into anything, how would the data be distributed? So the first one says Arizona Game and Fish is sampling fish out of a lake. The most two popular fish in there are bluegill, which are small, and pike, which are big. While some pike can be small, most are caught at an average length of 16 inches, rather big. While most bluegill are small, some can get to be about 10 inches, but most of them are going to be small. So what this tells me is we're going to have a lot of data points in the small range and in the big range, and not way too much in the middle. You got a bunch of small bluegill and you have a bunch of big pike. And then you have the ones in the middle that are pike that are growing up, or bluegill that are really big. So that one would be bimodal. The next one says Mr. James's test was way too easy. Some students struggled because they never pay attention, but most scored in the high B or A range. And that is saying that most of the data points is either going to be on the left or the right. In this case, it's going to be most of the data on the right. And as we just said, oddly, when all the data is on the right, we call that skewed left, because it's saying if you got like your bell curve, grabbed it and dragged it, you would have to drag it to the left for it to be the shape of a skewed graph. Number 3 says an IQ test is created to measure the intelligence of individuals. While there are some individuals that score extremely high and some that score extremely low, about 95% score between 70 and 130, with the average person scoring 100. And if you went over and plotted those, it ends up with most of the data concentrated in the middle, so that would be a bell-shaped. It's going to be symmetric and bell-shaped. And the last one says that we made a new pond in Flagstaff. They put in 104 inches, 105 inches, 106 inches, and 110 inches. Luke showed up on Wednesday and caught several fish, recording their lengths before throwing them back. All fish were equally active, meaning he was catching an equal amount of each one. So that would be uniform, because you would have just as many 4 inches as 5 inches, as so on. Now the next one here says, let's see, why is this looking funny? Let's go to the homework now. The homework, it looks like printed weird, or scanned in weird. So the first one says which of these would be symmetric. That would be B. So symmetric distribution would be B. The next one says which one would be skewed. That is D. And once again, that one, even though most of the data is on the left, that's called skewed right. The next one says identify how we would identify these. There are some low and middle income people that live in Telluride, but the majority of the citizens are extremely wealthy. That is going to be skewed. And once again, we got to call that skewed left, even though most of the data is on the right and the bigger incomes. B is you roll a fair-sided die 100 times, record the values. That is going to be uniform, because since it's a fair 6-sided die, you should be getting equal number of 1s, 2s, 3s, all the way to 6s. C, the average height of an American man is 5'9". As your height increases, there are less and less people who fit the criteria, and the same is true when they get shorter. So it means there's going to be not way too many ones that are super short, not ones that are super, super tall. Most of them are going to be around the center, which is 5'9". So that would be Bell symmetric. And then D, it says you decide to collect data on the heights of individuals that are in daycare during working hours. Occasionally, workers bring their own teens and tween children, but for the most part, they're only adults and toddlers, meaning there are going to be a lot of people who you measure who are really tall, adults, and people who you measure who are really small, toddlers. So that's going to be bimodal. And now let's go back over here. It says, what do you know given the histogram? Can you tell the following how it is distributed? So you can tell that there are 11 data points and it's somewhere between 4 and 30, not including 30, but you have no idea how those are going to be distributed. So that's the information. The next one, you guys were supposed to make a neat dot plot and box plot. You could see the ones that I got there. I originally had 4. I thought you guys would be tripped up by it because it turns out that the lowest number is 4 and Q1 was, or Q2 was also 4. Q1 was 4. So I switched it over from a 4 to a 3. And then this last one, it says the box plot represents the distribution of the numbers of points scored by a cross-country team at 12 meets. If possible, find the mean. We can't find it because we don't know what the data points are. We don't know what the sum of all of them are, and we don't know how many there are, so we can't divide by that number. B, if possible, find the median. You can find the median. The median is going to be 34. That is in the middle of the box. And the next one, did they ever get 30 points? We don't know. We know they went in that range, but we have no idea what the actual data points are. So we don't know. All right, hopefully that made sense. Once again, we are coming up with names to represent how the data is spread out. Is it concentrated in the middle? Is it concentrated on one side? Is it concentrated on the left and on the right? Or is it just uniform? All right, thanks for watching.